Okay, girls, so this rule, y equals negative x. So the difference with the following rules that we're going to have is this negative x that we have here. So with this negative x, what we have to think is what is happening to the y. So if x is equal to 0, y will still be 0 because negative 0, we never write negative 0, we write just 0. Agree? When x is 1, y is going to be negative 1. When x is 2, y is going to be negative 2. Perfect. When y is 3, y is going to be negative 3, and so on. Perfect. Okay, I want to point out to something here. I'm going to do it with yellow. What is the difference between 0 and negative 1? Negative 1. And we agree that each time I'm taking away 1, taking away 1, taking away 1, taking away 1. And this is consistent with the rule because I'm here, I have like a hidden negative 1x, but we never write that, and we know this from algebra notation. We write negative x. So I'm going to delete this to not create any confusion, so we write it like this, negative x. But I want to point out that here there is a hidden 1. Agree? Okay, so I'm going to start with, okay, so this Cartesian plane is not going to work. I want to delete this Cartesian plane, eraser. Good. I need this Cartesian plane with red. And I'm going to do it here with Cartesian plane. Good. I think this will work. Perfect. Okay. So I draw my arrows just to demonstrate that this goes forever and ever and doesn't end there. And the same with x axis. Fantastic. So I start with my first point, and my first point says 0, 0. So I'm starting here. 0, 0. Okay, and then the next point is going to be 1, negative 1. If we assume that each square is going to be 1, so this one is going to be 1, negative 1. And then 2, negative 2. And then 3, negative 3. Okay, if we continue what we were doing before, that was using the rule only with the first point, I want you to notice something. The negative is saying that I'm not moving upwards, I'm moving downwards. So this negative here is telling me you move 1 to the side, because we always move to the side first, and then we go downwards 1. And that's what we have been doing. 1 to the side, 1 down. 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 And if we draw this, it's going to look like something like this. And I can continue it forever and ever and ever and ever, as long as I want to go, because this rule will work for all these numbers as long as I go through all the dots that I just drew. Good. Beautiful. Okay, so that's D. Let's go into E. I'm going to put F a little bit further down. Down, 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 down. Good. I'm focusing on E. Okay, so in E we have 3x plus 1. Okay, so here we have to use a little bit of arithmetic. So for the first part, so if x is 0, this goes away and this becomes 1. Perfect. And then if x is 1, this is going to be negative 3 plus 1 is going to be negative 2. And then this is going to be negative 6 plus 1, negative 5. And then negative 9 plus 1, negative 8. Negative 12 plus 1, negative 11. Is that right? Yeah. And negative 15 plus 1, negative 14. Yep, working beautiful. Okay, so here we have our pattern. Again, we can see that this -3 is exactly the difference that is happening between these numbers here. Agree? Okay, and what is that telling me if I'm going to use it as a rule? That I move 1 to the side. Yes, because these numbers are consecutive. 0, 1, 2, 3, 4, 5. So that's why it's 1 to the side and then downwards 3. So let's use our Cartesian plane here. Good. Okay. I have my Cartesian plane there. Again, we draw the arrows to say that this goes forever and ever. And our x-axis. Beautiful. This time, only to make it look a little bit more clear, I'm going to use a different scale in x than what we have in y. Okay, in y I'm going to use that each square is going to represent 1. But for x I'm going to use 3 squares are 1. 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 So this is 1, 2, 3, 4, 5, 6. Whereas in y, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The same going downwards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 10, this one. Okay, I'm going to start with 0, 1, the first point, and then I'm going to use the rule to find the next ones. So my point is when x is 0, y is 1. So it starts here, that's my first point. Okay, and then I have to move. I'm going to what the rule says here. The rule saying 1 to the side, 3 down. So we're going to do this, what the rule is saying here. 1 to the side, 3 down. So 1 to the side, 1, 2, 3. And this is my second point. And then 1 to the side and 3 down. 1, 2, 3. And then 1 to the side and 3 down. 1 to the side, 1, 2, 3. I'm going to check that my points actually work. Did I did this correct? 1, 1, 2, 3. Yes. Okay. So if my points are correctly, I'm going to check with blue. So the first point 0, 1. Yeah, that is the one that I started. And 1, negative 2, 1. Oh, it didn't work. What did I did wrong? I'll tell you what I did wrong here, girls. When I went here, I'm going to check it here with blue. When I go here, 1 to the side and then 1, 2, 3. You see, I didn't count this step here. I started counting from the bottom, but it's from the point. So it's from this point I have to go 1 to the side and then 1, 2, 3. So the point should be this one, not the green one. So I'm going to delete the green one, and that means that the rest of my points are wrong. So we're going to change them now. It's good that I made that mistake in video, so you see what can go wrong with using this rule. And you have to be very careful. So now 1 to the side, 1, 2, 3. And then 1 to the side, 1, 2, 3. Okay, let's see if that works. So 1, negative 2, 1, negative 2. Beautiful. Then 2, negative 5, 2, 1, 2, 3, 4, 5 works. 3, negative 8, 3, 1, 2, 3, 4, 5, 6, 7, 8. Perfect. And if I wanted to continue, I could continue with the next one. Now I'm going to draw my line. So I start with one of these points here, and I just make sure that it goes through all those points, and I continue my line as much as I want. Beautiful, girls. I hope you find this useful.